Hello, everyone. We have been talking about matter. And in chemistry, the chemists looked at all of the matter in the world and had to make a decision of how do we classify it? How do we organize it? So they started by asking the question, can it be separated physically or can it not be separated physically? Well, we just got done talking about mixtures. Things that we can physically separate are called a mixture. But if you can't physically separate it, meaning that you must use a chemical reaction to separate two things, then chemists define those things as pure substances. And there are two types of pure substances, compounds and elements. So for the next couple of minutes, that's what we're going to talk about. The two types of pure substances, elements and compounds, are the most basic small bits and pieces that make up everything around us. Elements you're familiar with, gold, silver, copper, lead, these are the elements that make up the periodic table. And then compounds occur when these elements are combo packed into new wondrous bundles, and they make up things like water, table salt, sodium chloride. All of the elements can be found in one list, and we're going to spend a lot of time in this course talking about this list, and that list, of course, is the periodic table. Now, elements are the simplest form of any pure substance. They consist of only one type of atom. And even without looking at the periodic table, if I covered this up so you couldn't see it, I bet you could easily name 20 elements, even if you've never taken a chemistry class before, because they're so familiar in our everyday life. But things like oxygen, carbon, hydrogen, bromine, nitrogen, lead, copper, silver, gold, these are the unique different kinds of atoms, and these atoms are sort of the alphabet of the universe. These are the small bits and pieces that nature combinations, combo packs, to make everything from stars and planets to Doritos to wonderful cheeseburgers. Now, when individual atoms are combined in very specific groupings in very specific ways, those are called compounds. So compounds are defined as groups of two or more atoms that are chemically combined. They're not just sitting next to each other like two people on a bus. These are physically combined so that they are indistinguishable one from another. They are no longer one element. They are unique molecules. Now, once something converts from being an atom to a molecule, it has unique properties, different specific chemical properties than it had when it was an element. Compounds cannot be physically separated. You cannot go in with a little piece of tweezers and pull the hydrogens off of a water molecule. You can't do that. They are so tightly bound on an atomic level that they are one little molecule is the smallest piece you can get without some sort of chemical reaction. That's the only way that you're going to be able to separate a compound. You also need to know this word molecule. When you have groups of atoms that are bonded to form a compound, those groups are called molecules, and you're familiar with so many of them. Water molecule, carbon dioxide molecule, hydrogen peroxide, sodium chloride, little bit more complicated. We'll get into that later because that's actually a formula unit. We're not talking about that this second. But these are bonded bits and pieces that we're so familiar with that we talk about them in everyday life. These compounds we buy in the supermarket and we use all the time. Throughout this course, one of my goals is to give you a chemical vocabulary. You are not expected to memorize an awful lot of chemicals, but I want you out the other end to have a handful of common household chemicals that you know by their chemical name. So let's start building up that chemistry vocabulary, one of which is sodium bicarbonate. Sodium bicarbonate is a pure chemical compound that you can buy in the grocery store. This is, of course, plain old ordinary baking soda, and this is NaHCO3. There are molecules of this that are produced, and they are bound together to produce those sodium bicarbonate individual bunches. Hydrogen peroxide, it looks very similar to water, which is H2O, but this is H2O2. Hydrogen peroxide is the stuff that is used to cleanse wounds. If you get an infection or a cut or a boo-boo, this is also the stuff that will bubble if you pour it on a wound that has blood in it. Sugar. Table sugar is more precisely known as sucrose, and sucrose has a chemical formula, C12H22O11. And again, this is something you can buy in the grocery store that has a very specific chemical formula for each molecule of sucrose. There are lots of different kinds of sugar, but this is common table sugar. Ethanol. Ethanol is the chemical name for alcohol. There are many different types of alcohol, but we are talking about the alcohol that is used to drink. This is different than the kind of alcohol that is used to cleanse wounds or at the doctor's office. But the alcohol that you drink is called ethanol, and its chemical formula is C2H5OH. So each one of these is a compound. It has a specific chemical formula. Now let's take a look at these pictures. Just to kind of hopefully you've got the idea of what's an element or what's a compound. What I'm going to ask you to do now is this. Hit pause, spend 30 seconds looking at the pictures and identify compounds or elements, and then we're going to come back and go through them together. Okay, are you back? All right, here goes. Now, A, is this pictured an element or a compound? Well, I would say element. All of the pieces are exactly the same, and because they're all the same, this is an element. Now, what about B? This one is tricky, and we're going to talk a little bit more about this in a second. This is actually an element, but these are elements that bond to themselves. And so these are elemental molecules, and we'll talk about those a little bit later. So if you found that one a little tricky, you're forgiven. That's a little bit tricky at this point in the class. C, is that an element or a compound? I would say compound, because you've got a molecule with you've got an atom with two others that are attached, and each one of these looks exactly the same. Okay, my friends, what about D? D is kind of wacky. What the heck's going on there? Well, if you went, I'm not sure what's going on there, honest to goodness, I suspect what we've got here, and I didn't mean to be tricky, but really tricky, we've got a mixture of all sorts of things. These two are the same compound. These two are the same compound. So the two blue ones, these are the same compound. The two orange and red ones, these are the same compound. And the two little red guys, what do you think about this one and that one? Oh yeah, those are elements. So just to give you a visual of what we're talking about. Remember the last page I said that this B up here was a little bit tricky? Well, here's why it's tricky. There are things out there that are called elemental molecules. Elemental molecules exist when two or more atoms of the same element are bonded together. Some elements don't like to hang around one atom at a time. They just don't like it. They love to pair up. They love to team up with their own kind. Why? Well, it has to do with stability, and we'll go into more of that a little later in the course. But there are 7 that are very, very, very common. I refer to them throughout the course as the dirty 7. Why the dirty 7? Because they cause us challenges when we start making chemical reactions and balancing chemical reactions. But these are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These always hang out two at a time. They always make elemental molecules, and that means if you ever find pure oxygen, it's always O2. Pure chlorine, it's always Cl2. So it is a molecule, meaning a group of atoms bonded together, but it is only made of one element. All right, that will do for this one, and we'll talk to you later. Bye-bye.